Okay, welcome back. We are now on part two of lesson 7.4, dealing with the Pythagorean theorem and right triangles. So you might want to know, who really cares about the Pythagorean theorem? Well, sailors would. Okay, that would be one industry that would definitely care about this, or really any industry that has to navigate. So we want to look here, like how far is it to Nova Scotia from Nantucket? All you know is the latitude and longitude of both. So if these were the latitudes and longitudes of each of these, if we knew these numbers, so here's Nantucket, here's Nova Scotia, we can see that it goes on some straight trajectory, and we can make a right triangle out of that. And if we look at this, we notice one side has a length of 9, the other has a length of 12. So we know we could take 9 squared plus 12 squared equals c squared. But again, let's think about the pattern that we saw on the last page, where everything is 3, 4, 5, right? Or multiples of that. So 3 goes into this. It's a multiple of 3. So 3 times 3 is 9. 3 times 4 is 12. 3 times, and we know that C would be equal to 15 miles. Okay, we can see that based on this information. All right, so now let's move on to more examples. For each of these, find the missing side of each right triangle if you can. So some of these are going to be easier than others. So again, we've got 16, 12. So we've got 12 squared plus 16 squared equals x squared. Again, 3, 4, 5. So we know 12, 16, x should be 20, but we can always do the math as well. We'd have 144 plus the square of 16 equals 400, and then the square root of 400 is 20. Example number 2, now we actually do know the hypotenuse, so now we're looking at 6 squared plus x squared equals 10 squared. But again, if we think of 3, 4, 5, this is 6. So how do we get that down? We would divide it by 2, right? 2 into 6 gets us 3. 2 into 10 gets us 5. So x must be 8. Okay. Go ahead and pause the video. And I want you to try the rest of the exercises that are on this page. Okay. Try the rest that are on this page. All right. Now that you've unpaused, we can come back and we can do a few more of these. Again, we've got 9, 12, and then a hypotenuse. So again, we're looking at 9 squared plus 12 squared equals x squared. X is going to equal, again, 15. Again, 3, 4, 5. Okay? All right, 4. Let's look at 4. Oh, look, this is not a right triangle. Okay? This is actually an isosceles triangle. So we look at this, we can tell that these two sides are different from the base, but these two sides must be, and that's what this line means. These two sides are going to be equal. So this side is going to be 9 as well. Come here. Exercise number 5. 9. This is an equilateral triangle. That means all sides, all of them, are going to be the same. So all of them are 9. Then we go to this one. We've got 9, 8. This is not a right triangle. It's not an isosceles triangle. It's not an equilateral triangle. So how do we figure this hypotenuse? Well, we can't do it using the Pythagorean theorem. Okay, can't do it. Okay, so this one's no, we cannot perform that one. All right, this one, number 7. We can see we've got the hypotenuse is 5, 4. So we've got 4 squared plus x squared equals 5 squared. And again, we know all right triangles, 3, 4, 5. So x must be equal to 3. It's a very, very simple pattern. All right, we can look at this one. 6, 8. So we know we've got 6 squared plus 8 squared equals x squared. So we know again 3, 4, 5. So x is going to be equal to 10. Okay, because it's a multiple. You see, these are all multiples of 3, 4, 5. It's just they've all been multiplied by 2. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. Okay?